right, in this lesson, I'm going to go over finding circumference, which you've already actually done in our circles unit. So I'm going to focus, the majority of this video is going to be on finding arc length. So I'll kind of put these notes here so you can see on the screen real quick. And again, we'll have proven with one of our CLTs this arc length formula, all right, and it will be given to you in terms of on the theorem sheet. But I'll read it off for you for arc length. So in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So kind of the way my brain thinks of this is if you look at this part of the equation where it says 2 times pi times r, right? That is the circumference of a circle or the distance all the way around. And so if we want to find the measure of a particular arc that is on that circle, so a piece of the all the way around, we need to figure out the ratio of that amount of that arc, right, out of the whole circle, which is 360. So essentially we say, okay, what ratio of 360 are we looking at? And then multiply that ratio, that fraction, times the total circumference. That will give us the length of any arc on a circle. All right, so let's use that in practice. So we're going to start with first two questions by just finding the circumference. So something that I'm hoping you feel comfortable with. So this first one says to find the circumference of circle A. So I'm going to do circumference equals 2 times pi times the radius, right? Notice they're giving us the radius. They're giving us that 12 centimeters. So I'm going to plug that in to get 2 times pi times 12 centimeters. So in terms of pi, my circumference is 24 pi centimeters. Now it does say to approximate it. So I'm going to go to Desmos and type in 24 pi, which is approximately 75, I'll do the nearest tenth, 0.4 centimeters. Okay, let's do number 2. Number 2, same idea, circumference of a circle, but this time they're giving us the diameter. So I'll use the other formula for our circumference, which is pi times diameter. So pi times 30. So in terms of pi, my circumference is 30 pi feet. All right, I'm going to approximate it by multiplying 30 times pi, which is 94.2 feet approximately. Okay, so hopefully that's a quick refresher on circumference. So now getting into the actual new stuff here is finding arc lengths. So we'll start kind of basic. You notice as we go, you'll notice some that I've already finished because I can't do all of these in a video, otherwise it'd be too long. So it says the measure of arc BC is 90 degrees. So they've given us this 90-degree angle here, right there. And we also know that this arc length is 90 degrees. So, excuse me, the measure of that arc is 90 degrees. We're trying to find how much of the circumference of this circle is that arc BC. So the length of it, not just the measure of it, okay? So I'm going to do my formula, which is the length of arc BC is equal to the measure of that arc, which is going to, or that angle, which is, I'll say CAB, over, right, the entire circle, 360 degrees, times the circumference, 2 times pi times r. So I'm trying to find this. So I'm going to copy that down. We know this angle is a right angle. And we have 2 times pi times the radius of that 12 centimeters. Okay, so kind of cleaning this up, that's going to be 1/4, right? 90 over 90 over 360 is 936, which is 1/4, times, and I'll go ahead and write 24 pi over 1. So that's the length of this arc. And it does say to leave the answer in terms of pi. So I'll go ahead and finish this question by doing some division. 24 pi divided by 4 is going to be 6 pi, and in this case, centimeters. Okay, so that is how you find the length of this arc BC. Okay, I've already done 4. Let's do number 5. It says the measure of arc BE is 27 degrees. So you can see because of it is a central angle of EAB is also 27 degrees. So finding the length of arc BE is going to be that ratio of the measure of angle EAB over 360 degrees times the circumference. All right, let's plug in what we know. We know the angle is 27 degrees out of 360 times 2 times pi times that radius of 12 centimeters. All right, so this one I'm actually going to go to the calculator because it does say to round to the nearest hundredth. All right, so I'm going to put approximately and type this in. So 27 over 360 and then times 2 times pi times, I believe it's 12. I'll confirm those numbers. 27 over 360, 2 times 5, yes. Okay, so to the nearest hundredth is 5.65. To the nearest hundredth is 5.65 centimeters. So that is the length of arc BE. Okay, so now you get a chance to do some of that practice there. We're going to keep it going. All right, maybe have a few little twists with these. All right, you notice I've done 6, I've done 8, let's do 7. So it says find the length of the bolded arc to the nearest hundredth. All right, so again for this one, what I need this angle, right, that central angle that would give me the measure of that arc in degrees. If I know that, then I'm able to figure out the length of that arc that is bolded. So I'm going to say the length of the bolded arc is equal to the measure of that angle over 360 times 2 times pi times the radius. All right, so in this case, I'm going to find that length of that arc. The angle, all right, this is where I have to do a little bit of math to the side here. I need to do 360, all right, for that angle, minus 142 degrees, all right, in order to figure out what that angle is going to be. So if I subtract 360 minus 142, I get 218 degrees. So this angle is 280 degrees. So that is going to replace that angle there over 360 times 2 times pi times the radius of 4 centimeters. It does want me to round to the nearest hundredth, so I will be going into my calculator to get an approximation. So 218 over 360. All right, so 218 over 360, and then 2 times pi, I believe this is going to be 4. I'll confirm. Yes. All right, so the nearest hundredth is going to be approximately 15.22, in this case, centimeters. 15.22 centimeters. All right. Again, so that just had a little bit of a twist there where I needed to do a quick subtraction to find that measure of the angle. You also could do this question by finding the measure of this arc, right? Because you are given the 142 degrees and then subtracting that from the total circumference. You would get the same thing, right? If you wanted to see me do it, it's 142 over 360 and then times 2 times pi times 4. And then if you subtracted that from 2 times pi times 4, and you did minus the 9.91 approximately, right? You see we get the same thing, right? Obviously it's a little off because I rounded, but approximately 15.22. Again, so it's your call on how you do this. I went ahead and found the angle that allowed me to just go straight to finding the answer, but you could find the part of the arc, that length, and then subtract it from the total circumference. Okay, let's skip 8. We got, I think, 3 more to do. 9 is next, and then 9, 10, 11. Okay, so number 9. We circle W. It says VS is 12 meters, so I'm going to go ahead and just do that in my head. If VS is 12, then the radius is going to be 6 meters. All right, it wants us to find arc UT right here, arc UT. All right, so in order to do that, I need to know what the measure of that arc is in terms of degrees, or find this central angle, right? If I can figure out what either of those are, then I know I can find the arc length of UT. Now, I do see this 127 degrees for angle RWV, so I'm going to first find angle V, W, and U, which is 180 minus 127. So that's going to give me 53 degrees. All right, so this guy right there is 53. And then it wants me to figure out the remaining piece there for angle UWT is going to be that 53 from 90, because I have this 90-degree symbol to the right of it, so I know that this right here is also 90. So angle, I'll say UWT is 90 minus 53. All right, so that's going to be 37 degrees. All right, so we found the angle that we need in order to figure out this arc length for arc UT. So I'm going to say length of arc UT equals the measure of angle UWT out of 360, right? That's that ratio, times 2 times pi times the radius. So getting this arc length is going to be 37 degrees out of 360 times 2 times pi times 6 meters. All right, so going to my calculator, because I'm going to round to the nearest tenth. So 37 over 360, 37 over 360, and then times 2 times pi times, I think it was 6. Let's confirm. 2 times pi times 6, yes. All right, so if the nearest tenth is going to be 3.9 approximately, so 3.9 meters. For the length of that arc. All right, so that was a little bit of a couple of twists there. We had to find do kind of two subtractions to find that angle, that measure of that arc in degrees, or the central angle that allows us to use that formula. Okay, last two. All right, some word problems. So we've got a 16-inch pendulum swings through an angle of 40 degrees. How far does the tip of the pendulum travel in a single swing? So I'm going to try my best here to kind of draw the pendulum. All right, so there's my pendulum. And it looks like it's going, it said, in one swing, I have 40 degrees. So I'm just going to say that that's 40 degrees. Okay. And then in terms of how far does the tip travel, I'm going to try to figure out what this arc length is, right? The measure of that. Now, in order to do that, I'm going to go ahead and finish what I believe is the circle. My best circle there, not my best, but it'll work. All right. And it has a 16-inch pendulum. So this right here, let me highlight it. This right here is my radius. So my radius is 16 inches, which gives me everything I need to figure out what the length of that, how far the pendulum is traveling in a single swing. So I'm going to say the arc length is equal to the measure of that angle out of 360 times 2 times pi times the radius. So my arc length is 40 degrees out of 360 times 2 times pi times 16. All right, I'll go ahead and get this in terms of pi, and then we'll approximate it. So 40 over 360, that's 4 over 36, which is 1/9. Times, and that's going to be 32 pi. All right, and though I can't divide that anymore by anything, so my arc length is going to be 32 pi over 9 units. What is it, inches? So I'll go ahead and get my approximation, which is in to the nearest hundredth. All right, so 32 pi over 9. 32 pi divided by 9 gives us 11.17. 11.17 inches is how far the tip of the pendulum travels in one swing. Okay, last one, number 11. So we've got a car entering a roundabout. I don't even know if you guys know what a roundabout is. I have one in my neighborhood, but the first time I ever saw it was in Indiana. It was like, whoa, this is a lot. But anyway, I'll try to draw something for you if you've never been in one. The car travels 280 feet, then turns onto Perry Street coming out of the roundabout. And if the roundabout has a diameter of 150 feet, find the angle of rotation to the nearest degree the car traveled. So I'm going to try to draw a roundabout here. All right. And I'm going to say that they're coming in the roundabout from Mason Avenue. Okay. Now they're traveling, the car's driving, and then they're gonna exit it. I'll say like right here, right? So they're gonna exit, and we'll call that Perry Street. Okay? Now it does tell us that the car, right, the measure of that length of that arc is 280 feet. Right? It tells us that that's how far the car traveled. It also tells us that the diameter, I'll draw a diameter here, the diameter is 150 feet. So basically, can we figure out with this information the angle of rotation? So if the car is coming in head on, right, how much has it turned to get to to finish the roundabout, or at least to exit on Perry Street? So what I'm going to do is I'm going to do that measure of the arc length formula, which is the measure of that angle out of 360 times the circumference. All right, but this time it says in the problem I'm trying to find the angle of rotation. So I'm actually trying to solve for this angle. All right, I am given the arc length of 280 feet. I don't know the angle. I'll call that A over 360 times 2 times pi. And again, the diameter says 150 feet right here. So my radius is half of that, which is 75 feet. All right, so now I've got to use my algebra to isolate for A. All right, so I'll go ahead and put A here, and I am going to approximate it. It says to the nearest degree. All right, so what I'm going to do is, let me do one more step actually before I get that A right here. So let's go ahead and put some stuff together on the right side. 75 times 2. Actually, you know what? I'll do this. Let's cross out the 2 and the 360 to become 1 over 180. I like that better. So I'll write 75 pi over 180 times A. So essentially I need to move over the 75 pi and the 180. I'll move over the 180 first by multiplying. So 280 times 180. I'll do that first. And then I do need to divide by 75 pi. So then I will, let's see, I can put that in parentheses. And divide by, what did I say, 75 pi, I believe. All right, so that is my angle, and we're going to the nearest degree here. So approximately 214 degrees. So 214 degrees. That is the angle of rotation that this car has turned in terms of the how much it's traveled in the roundabout. Okay, you'll notice I've already done 12, so check out Canvas for the key on that. If you have any questions on this, make sure to refer back to your notes here at the beginning, where we look at the arc length for the first time. It'll take some time getting used to, especially using the calculator for the most part. This is the heaviest use of calculator we've ever done. So come see me in office hours if you have any questions. Good luck.